Let's say int x is a big number, this big number 2147483647. Int x is this big number. So now y is going to be x plus 1. So number should be this, right? But if you see out y, you will notice something else. What you will notice? You are getting a different value altogether, a negative value. Well, you have x which is positive and you are adding 1 to it which is again a positive. Then why are you getting y as a negative number? Adding 1 to this particular number should give us this number, but we are getting a negative sign altogether. So the question comes into mind, is something broken or C++ not working? Well, it's not like that. Because of the overflow, we have integer and long integer. Difference is just going to be the number of bits that they use to store the information. So let's take the example again that we just saw. Int x is equal to that big number, right? Now this int tells the system that it is a integer and it will have 4 bytes of information, that is 32 bit. So there are total 2 to the power 32 possible combinations you can store. Because this is a signed number, the leftmost bit we are going to use to identify whether number is positive or negative. We have already seen it, correct? So we can store 0 to 2 to the power 31 minus 1 positive numbers and minus 1 to 2 to the power minus 31 negative numbers. So let's look at this particular value, this. The value of x was this only, right? Now if you represent this into 32 bit, you get something like this. All of them are 1. Only the leftmost bit is 0. Now this 0 represents that this value is a positive value and it's okay. So this value is actually representing this particular value. This is a binary representation of this big number. Now what we are doing, we are adding 1 to it. So let's add. So if I add 1 to this particular number, I get something like this. So what is this number though? What does this number represents? That's the main question. Addition part is done. We have this value as x. We have added 1 to it. And now we got something like this. Now my question is, what is this value? Well, if you look at this particular bit, the leftmost bit, it says that this value is going to be a negative value. Okay, so sign is confirmed. It's going to be a negative value. Now we worry about the value which is stored by these bits. Now all of them are 0. This one tells us that this is going to be a negative number. So all the negative numbers are stored into the memory in 2's complement. So we need to convert it back so that we understand the magnitude. We know the sign. We just want to know the magnitude or the value, right? So we are going to follow the reverse process of 2's complement. We are just going to subtract minus 1 from it and then we are going to invert the bits. Let's do that. So why is this? We know that it's going to be 2's complement and the number is going to be a negative. So I'm just going to write a negative value here. We just don't know what value it's going to be or what magnitude it's going to be. To find that out, we follow the exact reverse approach of 2's complement. We subtract 1 from it. Okay, so this is the number that we have. We subtracted 1 from it, we got something like this. Now we are going to invert all the bits. Now we inverted all the bits. Now this is this value only, 2147483648. This value is represented as this big binary number. So we know the sign, we know the value. So x plus 1 is going to be negative of this number. So magnitude is this and sign we already knew that it is going to be minus because we have 1 here, the leftmost bit. So the value of y is going to be something like this, right? Now it should have been positive, this value only, not the negative this value. This happened because of the overflow. But how did we end up in overflow position? See, the value of x is this. The leftmost bit we are using for the sign. All the bits remaining are already covered. All of them are having value 1. So this is the max limit of storing an integer, a positive integer into a memory, a positive signed integer into a memory. So this is the limit. When you add 1 to it, that becomes an overflow condition. Now this overflow condition can provide you the weird answers. The value of n is this number. Now if you multiply n into n, well, it's again going to result in an overflow. The value of m will not be correct, it's going to be something garbage value, right? It will discard lots of bits that we actually want because n into n cannot be stored into 32-bit number. We need more bits for it. That's why we have long long, right? The difference between int and long long is just the amount of bit that is going to use to store. So long long actually uses 64 bits to store the information. Keep in mind these general guidelines. If you see an int, you can at max store 2 into 10 to the power 9. Don't even try to store any number bigger than this into an integer variable. Use long long for it. Do not use integer to store any number beyond 2 into 10 to the power 9. Just use long long. Okay? Large values or the multiplication that can result in large value. Look at this. N is this value. That is okay. It's not greater than 10 to the power 9. So it's okay to store this value into a variable n with type int. But now you are multiplying here, right? So after multiplying this value, it's just going to grow bigger than 10 to the power 9. So the value of m will be a garbage value, something different than what we expect it to be. That's why you need to use long long here. So whenever you write a code, always estimate the range of values by looking at the operations that you are going to perform. Also look at the conditions and the constraints. Before you choose the data type, you have to look at the constraints. That's the giveaway or takeaway from this particular video. Always remember this general idea that 2 into 10 to the power 9 is the max value that int can handle. Do not even think about storing any value greater than this into a variable that has type int. Use long long if you know that value is going to grow bigger than 2 into 10 to the power 9. In this case, we should have used long long instead of int for variable m.